Hello, everyone. Welcome and thanks for stopping by my session, PurpleSharp Automated Adversary Simulation. I'm really happy to be in this first adversary village at DEF CON. Yeah, during the next 30 minutes, what I want to do is I'd like to present to you the adversary simulation tool I've been working on for the past couple of years now, on and off, called PurpleSharp. My goal with this session and the tool itself is to encourage detection teams to integrate adversary simulation exercises and practices into their detection program, so to enhance their detection programs. Yeah, hopefully this is helpful for some of you, and let's go ahead and start. So we'll start with a quick introduction. First of all, let me introduce myself. My name is Mauricio Velazco. I'm currently part of Splunk's threat research team. Before that, I used to be part of a blue team. I used to run the threat management team or the detection team for a Fortune 500 organization. Did that for a few years, and before that, I was a pen tester. I love meeting new people and chatting about infosec and interesting topics. So I'll leave you my Twitter account here, where I share my work, other people's work. So do follow me on Twitter. If you're interested about adversary simulation, threat hunting, detection engineering, I invite you to visit my GitHub page, where you'll find resources for the work I've done in the past years and some of the talks I've given, the tools I've released, etc. But okay, let's move on. So today I want to start talking about why I wrote PurpleSharp, and as I mentioned before being a threat researcher, I used to run a blue team, and specifically, I built and deployed a detection program. And when I was building a detection program, I learned a lot of things from being a blue team. But one lesson I think I learned that was the most important lesson about leading a detection program, and I want to share with you guys. I firmly believe that detection engineers need the capability to generate attack telemetry in order to be successful at their jobs. Imagine a scenario where we have instrumented an environment where we are getting telemetry from networks, endpoints, applications, and you're centralizing that to an event pipeline through an analytics engine like a SIM or something like that, right? And detection engineers are creating detections, supporting detections, maintaining this complex architecture. When I was doing this, I realized that we can have all the data, all the telemetry, but if we don't have that telemetry generated by attack techniques, by executing the technique, detections engineers are always going to be limited, because you cannot write a detection if you don't know how an attack looks like, right? So like, I firmly believe that a detection team needs the capability to generate attack telemetry. In other words, I think detection teams need the capability to simulate techniques, to simulate attack techniques. And this is why I wrote PurpleSharp, right? PurpleSharp is an adversary simulation tool that executes adversary techniques within Windows Active Directory environment. It follows the attack method framework, for organization of the techniques. It's written in C Sharp. So for the attack simulations, what I use is .NET libraries wherever possible, and Windows 32 API calls where I can. And its main goal is to generate the attack telemetry that enables detection teams to build, test, and enhance detection controls. Okay, that's the main goal of the tool. One interesting thing is that PurpleSharp is not weaponized. Even though it executes techniques, it doesn't provide the output to the operator. So it's not weaponized. For example, when I'm doing a curve roasting attack, even though I'm getting a service ticket for that SPN, I don't get the hash back. I don't present the hash back. So it executes techniques, but it doesn't provide the output, and it doesn't help you in a red team. That's why it's what I call adversary simulation, right? Because The goal is to execute the technique to generate the telemetry, and not necessarily to execute the technique to move on to a different goal like a red team or a pen test would do. So now let's dive deep into PurpleSharp and how it works. Okay, and then after that we're gonna go to some demos. Okay, so there's 5 points I want to go over real quick in the next 10 minutes around PurpleSharp, and why I think it's different and why I think it's helpful. So first, flexibility. PurpleSharp is flexible. It's a simple C# assembly, right? When we used to do adversary simulation exercises in my previous job at the beginning, what we would do is work with command and control frameworks like open source and commercial, both of them, right? But we would always lose time on setting up the infrastructure, getting a shell back, infecting a host, getting a payload. And don't get me wrong, they definitely work well, right? But we needed to be a little bit more flexible, a little bit faster, right? So now with PurpleSharp, all I have to do is drop that C# binary and run it, right? Like no command and control, no reverse shells or anything like that. Another thing is that PurpleSharp supports JSON simulation playbooks. A lot of other tools do this, and I like to call this the simulation as code, where you can define a simulation playbook with JSON files, right? And each technique has different parameters supported. So let me look at an example here on the right. This is a playbook for a password spraying attack, okay? As you can see, I defined the technique, the password, even the protocol. You can define which protocol to use. I added here a sleep time, so we're gonna wait 30 seconds between each authentication event. We define the users that we're gonna spray. We define the target, right? So all the simulations supported by PurpleSharp come in a similar way. Flexible, easy to customize, a lot of different parameters to customize the specific execution of the technique. Here's two other examples. On the first one, this is how we create we execute the persistent technique to create a service, and on the right side to create a scheduled task. As you can see, we can define the name of the service, the command that it's going to be executed. Same for the scheduled task, right? Next point. One of the goals that I had when writing a simulation tool is that I wanted to be able to remote simulation deployment. I wanted to be able to execute techniques in remote hosts. Why is that? Because when you're executing techniques on your local network, you're only testing the local network's detection controls. I wanted to be able to drop that simulation far away on that network that is maybe in a different country, maybe in a different continent, without actually having to have someone there, right? So that was my goal. What I ended up doing is just leveraging native services of Windows, like SMB to copy the file, WMI to execute the file, and name pipes for communication. And of course, it has a couple of requirements. This means that when we want to deploy a simulation on a remote host, we're going to need to have network connectivity to these services, as well as administrative credentials to these remote hosts, right? Now, let's dive a little even deeper on how this works. There's three modules that work together. The orchestrator that runs on the operator's computer, the scout that runs on the simulation target, and the simulator that also runs on the simulation target. So these are three different modules that synchronize with each other to execute the simulation. Now, one important thing is these modules, they needed to share information, right, about the simulation. So what I'm using is name pipes and serialized objects so that they communicate over the network using name pipes. So I did this because in a previous version I was just using command line parameters, So I would have to copy those command line parameters and use them on the remote host. But that wasn't good OPSEC, right? Because you could see the parameters there and it was easy to detect that this was a simulation. But now there's no more parameters because all the communication, all the details about the simulations is flowing through name pipes from the orchestrator to the scout and from the scout to the simulator. Okay? At a high level, the way it works is that the orchestrator first copies itself using SMB to the target, similar like PSXEC, right? It copies itself. Then it uses WMI to execute the scout, right? The scout runs, which is essentially a service, like a name pipe service. The scout runs some recon tasks to get a little bit more information about the target host. And then the orchestrator starts talking to the scout over name pipes. They share information. Once everything's ready, the scout then executes the simulator, which is in charge of actually the actual simulation itself. I wanted to separate simulation deployment from simulation itself, which is why I separated these two. Okay. Yeah. This is just an example on the source code of like the scout. This is the scout service. As you can see, it starts a name pipe service, okay, and it waits for the orchestrator to connect to it. Once it connects to it, it receives an object. The object is the simulation request, which is essentially a small kind of like a protocol that I came up with on how to exchange this simulation details, right? So this is the simulation request that has a header, a type, and it has a simulation playbook, which has all the details about all the simulations that need to be executed. So yeah, you can look at the source code to see how that works. But it's pretty interesting, and I'm pretty happy with the results. Another requirement that I had when writing PurpleSharp is that when I was executing remote simulations, the challenge was that because I'm using WMI to execute the scout runs under the context of that service account that you use to deploy a simulation, right? But I wanted to get user impersonation because when I'm executing a remote technique, I know that there's a user logged on here. So I wanted my simulation to run under the context of that user that's logged in on that host at that time, right? So how do I achieve that? Well, I had a few approaches. My first approach was to play with tokens, and I used these API calls to duplicate tokens and to start a process with a token that I stole, because the scout runs in a high privilege mode, so it has access, it can get a handle to other processes. My second approach was to inject shellcode, so inject PurpleSharp as a shellcode to a remote process, because once I inject that, then I'm going to run under the context of that process and whoever owns that process. So I tested these two first approaches. They worked, but still they weren't what I needed. I ended up going in a different route. What I did was I used parent process ID spoofing technique, which allows me to do two things. One, the parent process of my simulator now is going to be is going to run under the context of the user who's logged in. So I'm breaking that parent-child process relationship between the scout and the simulator. And second, because I'm using Explorer.exe as the parent process, then the child process, the simulator, is also going to run under the context of that user. So I am stealing that token and leveraging that user's token that's logged in on that host without having to actually steal a token. I'm just using parent process ID spoofing, right? So now my simulator, thanks to this, runs under the context of that user, and that's pretty interesting because it allows me to execute my simulation under a real user, right? So we no longer have to have that service account simulating techniques, but now we have that real user that is able to authenticate to other hosts, is able to get Kerberos tickets. So now it looks like this is an actual user that has been compromised and is attacking the network, which is pretty cool. This is again just some code on how I do this. This is the scout, the function called runs scout service serialized, and as soon as the scout runs, it receives that protocol, that message from the orchestrator, like a SYN packet, and then automatically starts doing the recon. Okay, so it sends that back to the orchestrator. The orchestrator stages the attack, the simulation, and once the simulation is ready, the orchestrator sends an act command. And when that act command is received, if the OPSEC technique is PPID, what the scout runs, it runs the simulator using the parent process ID spoofing technique. Right. Again, you can look at the source code yourself and check this out, how this works. So what we end up getting is something like this, where, as you can see here, we have the scout running under the context of this PSharp account, which is a service account that you're going to use to remotely authenticate to host. But the simulator actually runs under the context of a real user that's logged in on this host. And the parent process is going to be Explorer, right? So now when this comes to an analyst, they're going to think that this is a real attack, and they're going to investigate it the right way, which is another reason that I built PurpleSharp. I wanted to test my team, my SOC team, and this is one way of doing this, because now this real user has real hosts, real data, real proxy logs, so they can hunt through this data and look for suspicious behavior. Another important thing for me was to execute the same technique in different variations. And why is that? Because I want to be able to bypass, or at least attempt to bypass, existing detections. And it helps me validate detection resilience. Here's an example. The technique PowerShell. The way PurpleSharp can execute them is two ways. One, just calling PowerShell.exe, right? And putting the command there, an encoded command. But also another way is using .NET and executing PowerShell, leveraging the .NET libraries without having to call PowerShell.exe. So there's two ways of executing this technique, and defenders should know how to detect these two ways. Here's a cooler example. You probably know about this technique, remote services. It's when you are able to, a lateral movement technique that allows you to execute code remotely by starting a remote service or by messing with a remote service, right? So there's three ways that I can support this. One, just using a negative binary sc.exe, which allows you to, if you have the right permissions on a remote host, it allows you to create a remote service and start a remote service. So this is how I do it on PurpleSharp. Second way is no longer using the command line, but now using Windows API calls. The API called create service that allows me to create a remote service remotely, and then I can also start that service remotely to execute that technique. But finally, and here's a way to bypass detections. The first two ways, what happens is that they both generate an event, a service creation event, which is a really cool way of detecting this technique. But with this third variation, we are no longer creating a new service, because what PurpleSharp does is going to find an existing service, modify it so that its binary path gets changed, gets updated to a malicious command, and then reverts it back, right? So now we bypass, we're still leveraging the Service Control Manager on that remote host to execute code, but we're no longer creating a new service. What we're doing now is modifying an existing service. And by the way, credits to the author. This is a technique that I first saw on this tool called SC Shell, and I just replicated it. So, three ways of executing this technique. Another example is password spraying. I know that within Active Directory, you can use password spraying with Kerberos and NTLM, and that looks different on the logs. So it could be a way to bypass detection, where PurpleSharp supports both Kerberos and NTLM just by leveraging the API call logon user, and I have to change a variable here, and that's all you have to change to force the authentication to happen over Kerberos instead of NTLM, or the opposite. So technique variations, right? Pretty interesting feature for PurpleSharp. Finally, another important thing for PurpleSharp is I wanted to have Active Directory support, meaning be able to execute techniques in Active Directory environments. Of course, PurpleSharp is a C# binary focused on Windows, but I also wanted to do more. So for example, PurpleSharp is able to interact with Active Directory and the domain members in the context of that logged user, right? It also supports LDAP queries for random target selection. So there are some techniques that require targets. For example, password spraying requires user targets, right? But a lateral movement technique requires host targets. So what I do with PurpleSharp is that you can define two variables, host target type or user target type. And what these variables define is which targets you want to attack. If you set these variables to 2, what happens is that PurpleSharp is going to automatically do random LDAP queries against the Active Directory and obtain random users, obtain random hosts, so you can target them in your simulation exercises. And when you're picking hosts, it actually does an extra check. It goes against LDAP, it gets a list of hosts, but also checks if those hosts are alive with a ping. It also checks with a quick port scan on specific ports to see if those hosts are responding or not. So it does some checks before returning just an LDAP result. So pretty interesting, because now I can pick random targets without having to define passwords, because remember, I'm leveraging that logged users token. So, and that user is already authenticated to the domain. So I'm just leveraging that to do all the queries without having to define passwords. So now that we've looked at a few ways of how PurpleSharp works, a few features of PurpleSharp, let me jump to the demos, okay? Now, what I'm going to do now, I'm going to stop the video and I need to set up my environment. But at a high level, this is what we're going to be looking at, right? I have a lab environment, a few, I think 10 Windows hosts. I'm using Windows Event Forwarding, and then I'm using a Splunk community version to get all those logs. And we're going to be executing techniques and looking at some dashboards, okay? So give me a minute. I'm going to set up my lab environment and I'll be right back. Okay, guys. Okay, so I'm back now, and let's look at the first demo. So on this first demo, we're going to execute 2 playbooks. On the first playbook, we're going to execute some reconnaissance or discovery techniques using the command line, so using native files, native Windows binaries. And then we're going to use the curve roasting attack. Okay. On the second playbook, we're going to execute these techniques on a different host. We're going to execute some similar reconnaissance techniques, but this time we're no longer going to use the command line to execute them, but we're going to use PowerShell commands. So that's going to look different on the logs. And finally, we're going to start executing some password spraying techniques from that host. Okay. All right, so let's jump to this demo real quick, guys. So I have my lab environment, as I was mentioning here. We have a bunch of hosts. I think it's 10 hosts. I don't know what I did here. Hold on, let me come back to this. Okay, so as I was saying, I have 10 VMs here, a domain environment, right? And I have this computer here, and as you can see, this computer is not part of the domain, okay? It's within a work group, and I have PurpleSharp. So what I'm going to do is from here, I'm going to deploy remote simulations to some of these hosts, okay? So let's start looking at the playbook. So for the first playbook, we have this playbook. Let's quickly go over it. So this is a remote playbook because I'm gonna, again, as I said, I'm gonna deploy the simulation against remote hosts on this network. I'm gonna use, this is gonna be the service account that is gonna be used to authenticate to those remote hosts. So for this first simulation, I'm gonna deploy to this Windows 10-1, which is this guy, and as you can see here, it has the March Simpson user logged in. Okay, so we're gonna execute simulation under the context of this user, thanks to PurpleSharp's user impersonation. We defined the scout and the path and sorry, the scout path and the simulator path, because they are also configurable, and this is where the simulation is going to come from, right? And then we start defining some techniques. System discovery using command line, account using command line. I'm not going to go over each one of these techniques. You can look at MITRE ATT&CK to see what they are. Finally, we're going to use a curve roasting techniques. We're going to use variation number 1, which means get a service ticket for all the service principal names that PurpleSharp can find, which is a noisy way of executing it, right? But PurpleSharp supports other ways as well. And I'm going to put a sleep time, because why not? I can put a sleep time. And on my second simulation, I'm going to run it against another host, Windows 10-2. Similar techniques, but now this time I'm going to use PowerShell. This is why I said the variation number 2 here. With PowerShell, with this variation 2, I'm going to use PowerShell. And I'm going to use 2 password spraying techniques. One using curve rows against 20 randomly picked users, as I mentioned on the slides. And on another password spraying attack, but this time we're going to authenticate to a remote host. So we're going to do a remote password spraying attack by finding a host, random host, and spraying it. Okay. So I'm going to execute this and then just pause the video so we don't have to wait for this to finish. Okay. So I define the password and here we go. So I'm going to stop the video and come back to this. I'll be right back. So once PurpleSharp is finished, we can go in and look at the results. Don't forget that PurpleSharp writes the results to a JSON file in case you want to do that, but for purpose of time, we'll just do this manually, okay? So 2 playbooks have executed. Let's look at the results. On the first one, we see that PurpleSharp authenticated to Windows 10-1 and started executing commands under this simulator, of course, under the context of a real user with this PID, and starts executing some enumeration commands using the command line. Nothing fancy here. Get some results back, right? We're gonna see that on Splunk in a minute. And then after that, it starts the curve roasting technique. So it queries LDAP for SPNs, it finds them, and it starts getting a service ticket for each one of them, executing curve rows. And as you can see, waits 1 second per each authentication event because we define that sleep time. Okay. Finally, actually, let's come back to the logs to see how this looks like. So if I refresh this dashboard that I have here, we can see that in fact this host, Windows 10-1, and this user, March Simpson, executed a bunch of weird enumeration commands, right? But here's the interesting things. If we look at this curve roasting dashboard, we see that in fact Windows 10-1 and March Simpson started getting service tickets for all these service accounts and waiting 1 second between each authentication event, as you can see here. And so that looks pretty interesting, right? So now let's look at the results of the second playbook. On the second playbook, now we started doing some enumeration, but now this time we use PowerShell instead of the command line. So we're going to look at that. And finally, PurpleSharp was going to execute password spraying attack against random users using curve rows, and then now another password spraying attack against another host using NTLM, right? So if we look at our enumeration dashboard, now we see that this host, Windows 10-1, started executing a bunch of PowerShell commands that are used for enumeration, right? And if we look at how it looks like on the command line, we just see that a bunch of PowerShell being executed, which is not helpful. But if you have PowerShell logs, we can see this, right? And finally, if we look at the password spraying dashboard that we have here, we can see, hopefully, that this guy password sprayed against 19 users, random users picked up at PurpleSharp. This is with curve rows. This is with NTLM because PurpleSharp also supports NTLM. Here we can see another way of catching this technique from the simulator, how the simulator attempted to authenticate with these 10 users. So yeah, you get the idea, right? Like different attacks, different ways of detecting it. Okay, Cool. All right. So now, real quick, we're gonna move to the next demo. In the next 4 minutes that we have here, this guys we're gonna use lateral movement. Okay. Now, the cool thing is that we're gonna execute these techniques on a remote host, and the user that's logged in on this remote host, if they have the privileges, we're gonna be able to execute code remotely. Okay. So let's continue to this demo. Okay, so now we have a different playbook, this playbook, and now we're gonna execute the service creation and, oh, before I jump there, let's look at the details. So now we're gonna be using the four most common lateral movement techniques in Windows environments. We're gonna use remote services to create a remote service, schedule tasks to create a remote scheduled task. We're gonna use WMI and WinRM. PurpleSharp supports all four of them. And also we're gonna use some network service scanning, so scan some ports on some random host, and we're also gonna do some network share enumeration. Why not? Okay. Okay. So let's jump to our operator computer. We have the playbook here. This playbook is going to execute against Windows 10-2. Actually, both both tasks on the first playbook are going to execute against Windows 10-2. The reason behind that is that on Windows 10-2 we have a user, Mr. Burns, and Mr. Burns, he's a local admin on all Windows 10 endpoints. So which is what we need to be able to successfully move laterally. Okay. So in this first technique, we define, like I said, the scout, the simulator. First, we're gonna randomly scan hosts, like pick random hosts and scan them. Why not? And then we're gonna first create and start a remote schedule task on Windows 10-3. I think this is wrong here. Windows 10-3, as you can see here. Using the command line, so using SEH tasks. Okay, and then we're gonna create and start a remote service on also Windows 10-3, this time using the API called create service, and this is the command that we're gonna execute as part of the service. Actually, against Windows 10-4, sorry about that. The target is Windows 10-4, okay? And on the second playbook, we're gonna execute commands remotely using WMI and WinRM. As you can see here, this one is first, actually, we're gonna use some network share enumeration. Why not? Against 5 random hosts. Then we're gonna execute code remotely using WMI against 5 random hosts here. As you can see, we define host target type 2, which picks random targets, 5 for a total of 5 random targets, and we're gonna execute this command. Why not? And then using WinRM, executing against 5 other random hosts using WinRM. And finally, we're going to execute a variation of that same technique, PSExec or remote services. But in this time, we're going to go over against Windows 2019-1. And there's a service here called PurpleSharp service. As you can see here, Net Flanders, there's a service called PurpleSharp service, okay? And this PurpleSharp service has Notepad. What PurpleSharp is going to do is going to authenticate to a host and then change the configuration of that service. So instead of Notepad, we execute PowerShell and then moves that service back to its original configuration. Okay. All right. So we execute demo 2. And let me just make sure that our hosts are up and running. Oh, I'm missing one, so give me 1 second. Okay, I'm back. And one thing that I forgot to mention is for the second playbook that executes code on random hosts, I'm going to run it again Windows 10-4. And why is that? Because on Windows 10-4, I have Mr. Smithers logged in, and Mr. Smithers, he's a domain admin, so he's going to be able to execute code remotely on any host, which is what we want because we're going to pick random hosts. Okay, so let's execute this now, and let me just confirm that these guys are all up and running. Yeah, this guy needs to come back. Okay, so we execute it and we pass that service account password, and just like before, I'm going to stop the video so we don't have to wait for this to finish and come back. Okay, So PurpleSharp finished, and let's quickly take a look at this. So the first playbook we run against Windows 10-2, right? So we're running under Mr. Burns right here, and we create a scheduled task on a remote host, and then we now create a remote service against Windows 10-4. As we can see here, PurpleSharp generated a random service name and use Windows API calls to create, start, and delete that service. So let's take a look at how this looks on the logs. So first, if we look at what Windows 10-2 did, we can see that it actually executed SCH task to create a remote task on this remote host, again under the context of Mr. Burns, right? And if we look at this dashboard that I have here, looking for object changes, we can see that a schedule task was created on Windows 10-3, right? Legit task, as we saw here, run DLL. And finally, we also see this service account with a random name that matches that name that we saw on the logs, and MSHTA was executed on Windows 10-4, right? So this is how we caught this. And if we move on to the last playbook, now we're gonna execute code using WM. First we do some network share enumeration. I'm not gonna, because of time, I'm not gonna go over the results. We're just gonna go over the lateral movement. So now we're gonna be using WMI to execute code on 5 hosts remotely, and then WinRM to execute code on 5 other hosts remotely. In the first case, MSI exec, in the second case, RecSVR32. So if we look at parent process relationship logs here, and if we refresh this, we're gonna see the child processes of WMI PRVSE.exe, MSI exec, as you can see here, right? So this is how we caught this lateral movement technique. And finally, moving on with PowerShell, because when you execute code using WinRM, we see a different command executing on this host that PurpleSharp executed remote code on using WinRM. And finally, for the last task of this playbook, we connected to Windows 2019-1, and then we identify the PurpleSharp service that it was using notepad.exe. So now PurpleSharp is going to change its configuration to run PowerShell, start that service, and then move it back. Of course, we confirm this because we did not get a service creation event. But if you look here, we did see services.exe spawning PowerShell.exe on Windows 2019-1. So this was successful, but we bypassed some detection, right? So that concludes my demos, guys, and I think it's right on time, a little bit over, but good on time. If you like PurpleSharp, here's some documentation. If you like it, do give me a star on GitHub. If you have any feedback, you want to help with the project, please, you're more than welcome. And by the way, all these JSON playbooks, I'm creating a database of, or more like a centralized repository of playbooks, so you can look at this project to start getting some ideas on simulations. So that's it for me, guys. Thanks a lot, and yeah, you have a great day.